Okay, everyone, welcome to this first lecture on Spark that we are starting at Hadoop Express. And I think most of you already know me. For those who don't, I'm the lead instructor at Hadoop Express, and I'm responsible for coordinating all activities at Hadoop Express, pretty much the founder. In this exciting lecture today, what we're going to learn about is Apache Spark. It's one of the hottest tools in the market, as we all know. For the time being, I've muted everybody. In case you want to raise any question, you can definitely stop me in between and unmute yourself, and you should be able to speak out your question. If you want to stop me anytime, that's fine. In the interest of time, we'll go pretty quickly on the slides that we have. This real reason for this lecture today is to generate interest and also to get you started on Apache Spark. As we all know that employers today are looking for a lot of Spark talent and they're not finding it, especially in the US market. Most people who are working on Spark, developers, etc., are in India or Asia in general. And there is a great demand for architects and developers in US. And people who have worked earlier on different programming languages or have an experience on different platforms are today being asked by employers to also have some Spark experience, because this technology is really very revolutionizing, and it's really being liked by a lot of different sectors. So let's delve into this topic, Apache Spark. Very exciting. I was really very impressed by this technology, and the more I read about it, the more I learn it, the more interested I get in knowing more about it. And I'm sure you'll also find the same. Let's start on this. So our agenda today is going to be to discuss what is Spark, what are the major vendors and users that are using it, what are the key features, Hadoop, how does it compare with Spark, the architecture of Spark. We'll talk about a very important concept called Spark streaming. We'll see how Spark does processing, and we'll take some examples and use cases. So it's a very quick 1 hour demo and presentation. I'm sure you'll find it very interesting. I think a lot of you already know about Hadoop, so you'll be able to run some comparisons and see how Spark compares with it. I hope my voice is audible and to everybody. If not, just let me know at this moment, and I'll adjust the settings. So if any one of you can just unmute yourself and let me know if you're hearing me clearly.
I can hear you clear.
Okay, great. If you can hear me in India, that means it should be great. Okay. So what is Apache Spark? That will be the first topic. Apache Spark is considered an open source, big data processing framework built around speed, ease of use, and sophisticated analytics. We'll see how it provides all these different features today, but it really came into prominence because of the immense amount of speed it offers. We already had Hadoop, there was already MapReduce, and now we have Spark. We had a lot of different products like Pig and Hive and Scoop and different products. Huge family of products that's coming up in Hadoop in general. Spark was actually started in this AMP lab at the University of California, Berkeley in 2009. So it actually started after Hadoop. It didn't start before it. And the real reason that they looked at Spark was because they found that it would be interesting to do something which runs faster and can be run in memory as data arrives in huge quantities, and can be something that can be used for analyzing large data sets at a much faster pace than what they were finding in MapReduce. So considering the factor of speed was very important, and also the ease of use, so Spark you will find is very easy to use, and it also provides some very sophisticated features by using some components that we are going to look at today. So it started in 2009, and later on in 2010, it was adopted by Apache as an open source project, and then it became a top level project in Apache in 2014. So it's not too old. till very recently, it was really not a stable release. And from this year onwards, you can say that Apache Spark has become quite stable. And a lot of companies are having a lot of interest in getting talent for this product. It was first discussed in the Mesos white paper created in AMP Lab. So what is Mesos? For those of you who have looked at Yarn, you remember that it's actually a product that allows you to manage a cluster. So Mesos is similar to that product. It allows you to manage clusters, and allow you to manage clusters means different servers which are available in a cluster across a distributed platform. Yarn and Mesos are typically the two products which are available in open source that people are using today. And Spark is optimized to run in memory. So this is a huge difference between Spark and MapReduce, which was there already existing in Hadoop. So Spark actually allows you to run queries in memory and also to run analytics in memory. So naturally it runs faster. It's not that Spark has to run in memory all the time. You could do batch processing in Spark as well. I mean processing on Spark such that the data resides on the hard disk as well. But it's really an advantage to run a lot of queries and data analytics in memory because it makes it work up to 100 times faster than MapReduce when it's run in memory. And benchmarks have shown that it's about 10 times faster than MapReduce, even if it's working on the disk. So if you remember in MapReduce, you have two stages, map stage and a reduce stage. Between the map and the reduce stage, there is intermediate data that's residing on disks because the MapReduce framework creates some intermediate data as binary files. It stores it on the disk, and the reduce phase then takes it up and then aggregates the data. So data has to constantly go from memory to disk when you're using MapReduce. But with Spark, the advantage is that you could actually run the entire thing in memory with nothing being written on the hard disk at all. And that's one of the key features of Spark. But like I said, you don't have to run everything in memory. You could also use cases where you could actually write data to disk in Spark as well. Even in that case, it's going to be running much faster, like about 10 times faster than MapReduce. Further on, Spark, as it's mentioned over here, is a general purpose data processing engine suitable for use in a wide range of circumstances. You can run interactive queries using Spark. We'll see a little later, but it does have a SQL feature that you could use to analyze data sets. There's a streaming data that it can use. So this is a new concept, streaming data, which means basically that as the data is getting generated or coming in from some sources, it's streaming in, and you could actually, as the data streams in, analyze the data in almost real time. And a lot of financial systems, as well as other IoT-based systems, which we'll talk about again a little later, also use Spark for doing almost very near to real-time analysis. It supports other data processing tasks with developer libraries and APIs. It also, so basically Spark is used with 3 or 4 languages, primarily Java, Python, and Scala, and R, very lately this year, has also been integrated as a product within Spark. So if you already know something about Java or Python or Scala, you'll find it easy to program in Spark. It's often used alongside Hadoop's HDFS system. So we'll see what's the difference and how is it that Spark can be used with the HDFS. And it can also integrate equally well with other popular data storage systems like HBase, Cassandra, MapRDB, MongoDB, and Amazon's S3. So these are the common platforms with which you use Spark. It's often used alongside Hadoop's HDFS, as we talked, and it can integrate well. Oh, okay, this is just a repetition. Sorry about this. So who all are the major vendors of Spark? Spark today is heavily used by these 4 vendors. They are providing the support on Spark. Databricks, which was founded very recently. It's It's actually a company created by the founders of Spark at Berkeley. So they have been going into quite a significant amount of hiring of people for Spark as they are growing their capability on it. And I think they're trying to capture the market for support for this Spark product. Cloudera, as we already know, is already like one of the leading vendors for Hadoop and big data. And they are also very much into Spark. Hortonworks offers Spark support as well as MapR. So these are the top companies. Major users, there are more than 1,000 organizations that have already moved Spark to production. You know, some of the major or big players are IBM, Huawei, Baidu, Alibaba Tower. All these are basically, these are commerce or e-com websites. There's one company called Tencent. It's a social networking site, and it's got 800 million users. It's the largest user of Spark because it's using something like 8,000 compute nodes to run parallelized data across Spark platforms. We have also Amazon, eBay, Yahoo, and many other companies that are using it. So it's getting very, very popular. So the key features of this product are it's very simple to use. It has a rich set of APIs. So essentially everything works in Spark using these APIs. Just like if you remember in Hadoop, we have everything created as APIs in Java. In Spark, we have a lot of APIs which are also available, and all these APIs help you to create programs which are used for storing data, for analyzing data, running queries against data, and analyzing data at scale as it arrives in real time. It's very well documented and structured, and one of the key features is speed. So as we talked earlier, since it runs in memory, it can go extremely fast. And there was a benchmark or a test that was conducted in 2014 at Daytona Gray Sword Benchmarking Challenge. And there it was found that 100 terabytes of data on solid state drives were processed in 23 minutes by Spark. And this was beating the earlier record that was held by Hadoop, which used to take 72 minutes. Okay. So if there's no question, I'll keep going forward. If you have anything to ask at this point, feel free to ask me. There are other features as well for Spark. One of the prime one, like I said earlier, is stream processing. So it can process streams of data from multiple sources simultaneously. We'll talk a lot about this a little later. Machine learning. So as you are aware, there's a lot of talk about machine learning these days. It's used a lot in predictive analysis. What machine learning really entails is, when you are actually trying to run algorithms against data, then you can actually use those algorithms again and again and keep modifying the algorithm a little based upon the results that are obtained. So this is one feature that's being used by data scientists a lot, like using tools like R and SAS, etc. And R is now integrated with Spark, so we do have a lot of machine learning that's possible using Spark. Interactive analytics, this means that you run analytics as you see the data coming in. So you could actually have data which is constantly getting generated in memory. Maybe it's coming from multiple sources, like it could be coming from the web, it could be coming from sensors, it could be coming from mobile phones or something continuously. And as the data is arriving, you could actually query it using Spark, and we'll see how the architecture works and how does it enable it. But that's one of the very interesting and exciting features of Spark. So you could run a query, you could alter the query, see what results you get, etc. It's an interactive mode that you could be working in, which basically means you could be sitting on a shell in Spark. Just like you have a Unix shell when you run a Unix application. Similarly, if you start a Spark shell, you could actually start running your queries, and as the data keeps coming in, your query will be returning different results, but you could keep modifying your query as well and checking out what results you get. Data integration. So Spark and Hadoop are increasingly being used to reduce the cost and time required for ETL processes. So what's interesting about integration aspect of Spark is, there are some ETL tools. ETL means extract, transform, and load. So one of the popular ones, for example, is Informatica, and there are, of course, others, a lot of other tools, Talend, and many more. But essentially, what ETL tools do is they extract data from some sources. Let's say you have structured data lying in Oracle and DB2 or other platforms. You continuously bring that data into a data warehouse. So typically, ETL tools are used to get data into a warehouse. The difference between Spark and those tools is that Spark allows you to do ETL, that is extract, transform, and load, pretty much continually as the data is arriving. For example, if you were to do it using the traditional ETL tools, everything is done in a batch mode. Data arrives, you have some programs written that are going to transform the data, clean the data, and then the data is pushed into data stores. All this is done, in subsequent steps, and it's not done like in a continuous fashion. With Spark, you could be running data as soon as it arrives can get transformed and stored into the data stores, almost instantly. So there's a huge difference, and this is one field which is definitely going to grow a lot, and it's ETL tools are so much popular that people are finding it very exciting that Spark allows you to move data very quickly to data stores. So these are the languages as we spoke earlier. Scala, which may not be all that popular, but now it's gaining significance because of Spark. And besides Scala, there are these other languages as well, but it might be a good idea to learn a little bit of Spark if you're going into Spark, like learn a little bit of Scala, because Scala is a language that allows you to do some things in very few commands. Like instead of writing like 100 lines, you could just write 4 or 5 lines and it would pretty much do the same job. And it's very much object-oriented, and it is, if you know Java or other object-oriented programming languages, it won't be too hard to master this, but it does require some amount of practice, and it can get very exciting to actually learn this new language. So I would really encourage you to do it, even if you know these other languages. However, you don't have to know Scala to be, running something in Spark. Even if you're a Python programmer or if you know Java, that's good enough. You don't really need to know any of these other languages. So as long as you know any of these, you could actually be a good programmer on Spark. Okay. Now, how does Spark and Hadoop compare? Like, what's the difference, and can they run together? So Hadoop has a cluster management feature. Like, for example, we've seen how Yarn, if you remember, there are like different capacity scheduler, there's a FIFO scheduler, and there's also something called a fair scheduler that Yarn uses. So it has that scheduling capability. So you can schedule your jobs in Yarn. That kind of a capability is missing in Spark. So whenever Spark needs to run, it needs a cluster management software. So very typically it uses Yarn, which is a product that came about after Hadoop was born. So it kind of complements Spark. So if you have Spark running, you would need something like Yarn, or as I said before, there's another product called Mesos, which you could also use, which was also developed by the University of California at Berkeley. Spark can run on top of Hadoop and utilize its cluster manager. So you don't need Hadoop to actually run Spark. You could, because Spark is totally a different product. However, it can run on top of Hadoop, and there's a great advantage actually in running it on top of Hadoop. Because once you run Spark on top of Hadoop, it utilizes its cluster manager called Yarn, and it's able to use some data storage capabilities that are provided by default by Hadoop. Spark is not designed for data management and cluster management, which are handled very well by Hadoop. Hadoop provides, some advanced data security. This is missing in Spark. Like Hadoop can use something called Kerberos, which is a security software. So essentially, Hadoop has some security aspects that can be, borrowed. And when you run Spark with Hadoop, you get advantage of getting those data security features as well. Hadoop provides disaster recovery capabilities to Spark, which is otherwise missing. Like, for example, when you're running Hadoop, there are default like replication features which come with Hadoop. Also, there are multiple ways in which you can have disaster recovery configured in Hadoop. And this is a feature that's lacking in Spark. So if you had Hadoop running with Spark, you get this additional advantage. And now, so if all these are great things that Hadoop is providing to Spark, what about Spark? What does it provide to Hadoop? So Hadoop provides in-memory data processing, as we spoke earlier. So this is in-memory data processing, which is actually missing in MapReduce framework of Hadoop. So Spark, bridges that gap. So if you were to actually run your entire data process from the map stage to the reduce stage to the aggregated results, you could not do that in memory in Hadoop. Now Spark allows you to do that. So if you have Spark sitting on top of Hadoop, you can actually do in-memory data processing. Spark provides for enterprise class streaming, graph processing, and machine learning capabilities. We'll look at all of these one by one. So talking about integrations a little bit more before we delve deeper into architecture, Spark can be run in 3 modes. One is a standalone cluster mode, which means basically that you run Spark. You could run it on your laptop. You could run it on a Mac laptop or a Windows laptop. It will work fine. You could run it on a VM in the cloud, as you've seen in some of our classes, where we actually created an Amazon cloud instance. So you get hold of a VM in the cloud, like a Unix or a Linux server, and you could just deploy Spark on it on a single machine, and it will run pretty good. It can run on Hadoop Yarn and or on Meso. So you'll require one of these 2 cluster managers to actually make Spark work. So that's all mentioned out here. So Spark uses Hadoop. It can work with Cassandra, HBase. Cassandra and HBase are really databases. So it could use one of these NoSQL databases and interact with it. So your data could be residing in these as you run queries on Spark or data processing on Spark. So these are different products which are very commonly used when we talk about, creating platforms on Spark. So you would have Spark, you could have Hadoop, you could have Mesos, Cassandra, HBase. These are the kind of products that you'll be dealing with. Okay.
I have a question, Shashi.
Yes, go ahead.
You mentioned so far these various technical applications like HDFS, Cassandra, etc. And is any of these or something which is not listed currently used for bringing in streaming data which Spark can act upon immediately?
Yes.
What would you be for streaming data? Is it something like Flume or something else?
Yes, definitely. These are only some of the examples that have been given over here, but over here, what we're showing actually are the destinations. Like when you've got your data from data sources and you want to store it somewhere, then that store can be a Cassandra, a Hive, HBase, Tachyon, or other products.
Okay. Now, my question was on the flip side, that which tools are used for bringing in streaming data which Spark can act upon immediately?
Yeah, that's a very good question. With the beauty of Spark is that Spark does integrate very well with some ODBC and JDBC products. So basically, any product which allows you connectivity like that, you can bring pretty much any kind of data into Spark. You could connect to an Oracle database or any other structured database, MySQL or any other, and get that structured data into Spark. So those can be your data sources, or you could also bring in text files or a lot of different types of files, Paraquat files, the Avro files. It pretty much integrates with all kind of data that's available.
Okay, but for a streaming type of data, is there any particular API that it has to adhere to process that streaming data, live streaming data?
Yes. We'll see a little later. What you essentially do is there's something called a Spark context that you create, and once you create that Spark context, you could there are APIs that you actually use to bring the data into Spark.
Okay.
right? So this is the technology stack that comes with Spark. One of the things is the Spark core engine. So we will see what the core engine contains. There's something called RDDs that you talk about in Spark. The core engine actually deals with that. We'll see how. We already talked about these products at the bottom. These are not really, Yarn and Mesos is not really a Spark product. And a standalone scheduler comes bundled with Spark. The moment you install it, let's say you're just working in a dev environment, or you want to do something on a standalone machine for yourself to play around, then you could actually install Spark. You automatically get a standalone scheduler. So you don't really need Yarn or Mesos working. You could just have a standalone scheduler. So that will work very fine with Spark. And along with this, what's more interesting is all these different components that we have in the technology stack. One is the Spark SQL, as the name suggests. It's the structured query language that comes bundled with Spark. So you could start using it by default as soon as you install Spark. There's something called Spark streaming. So all these different components have their own set of APIs. mlib is a machine learning library. Graphics is a graph computation. So this graphics product allows you to manipulate graph data. Spark R, which allows you to run analytics using R on Spark. So data scientists can utilize the advantages of Hadoop, for example, storing data in Hadoop when they use R with Spark. So we'll see how these different components work one by one. But this is the entire technology stack that comes with Spark. These four products over here, Spark SQL, streaming, mlib, and graphics, these were the only ones available till the little earlier versions, but more recently, since late 2015 or earlier this year, Spark R has also been integrated into the technology stack. So we'll talk now one by one about these components. Spark core engine. What's the core engine? The core engine is really providing the basic functionality of Spark. It uses RDDs, like I said. So what are RDDs? It's a new concept. It's called resilient distributed data sets. So these resilient distributed data sets are really the data elements that we have. And Spark allows you to deal with them. And we'll see in a little while what exactly are these RDDs, what do they contain. And we have APIs for manipulating these RDDs, essentially. So the Spark core engine contains these APIs, which actually help you in dealing with the RDDs as they are created when the data flows in from different sources. So Spark RDDs are a collection of items which are distributed across compute nodes. And Spark core APIs allow manipulation of these RDDs in parallel. So this means that the RDDs are not just, it's not just one single data set that you deal with. You deal with multiple RDDs, and all of them are processed in parallel when you use the APIs from Spark. Okay. So now we'll talk about these different components. One is the Spark SQL. This is just like a query language. So the advantage of using Spark SQL is you can combine data which is already existing in your data destinations. For example, if you already have data in Hadoop, or if you already have structured data lying on some other data source, you could run your query in such a fashion that you are not only analyzing data which is already stored somewhere, but also data which is arriving continuously when you use Spark streaming. So that's the advantage of this Spark SQL. So it combines your historical data which is already structured and lying somewhere with the data which is coming in rapidly from different sources. No other tool provides this capability. It allows querying with SQL and HiveQL, and the data sources can be, so this kind of like is a little bit of the question that you asked earlier, Ravi. So it's like data sources can be of multiple different types. It's not just these which are mentioned over here, but yeah, Flume you mentioned, of course, yes, Flume, which is a product which actually allows you to collect data from logs across the web. You could have streaming data coming in from different logs that you're generating and collecting from different sources on the web. And you could integrate that with Spark. So all that data can be collected from Flume. So Flume's output could be sent to Spark, and then Spark can analyze it. The same is true for all different types of data as well. It could be JSON files, it could be Paraquet files, Avro files. There's a huge variety of data sources that Spark allows you to interact with. So it allows intermixing of SQL with programmatic manipulation of RDDs in Python, Scala, and Java. Okay. Now, if you were actually looking at some earlier books and literature on Spark, you will find that Shark is mentioned a lot. So it's nothing but the older version of Spark SQL. So what used to be Shark, which was also developed by the University of California at Berkeley, is now Spark SQL. Okay. So Shark is an older version of it. Spark streaming, which is one of the most important and interesting components of Spark, is used for processing live streams of data. So it's live streams. It's not data which is resting somewhere. It's just continuously coming in. And as it comes in, you can actually start analyzing it. What types of data? It could be log files, it could be message queues, or it could be any kind of text files that somebody is sending across. It could be sensor data coming in from mobile devices. It could be, let's say, if you've seen applications such as wristbands on Fitbit that you get these days, which can monitor your heartbeat and pulse rate on the fly and instantly. So you can just wrap a wristband on your wrist, and you can get readings on how many steps you walked, and what's your heartbeat, and readings of that kind. So that's IoT, where sensor data is sent streaming across and analyzed on the fly. So that kind of IoT application data is something that Spark deals with very beautifully. It can manipulate data stored on disk or in memory as the data arrives in real time. Okay. It also offers high throughput and is fault tolerant and scalable. And MLib is the machine learning library. So it provides ML algorithms. For example, clustering, regression analysis, classification, filtering. These are all features of any machine learning language. And using this particular component, you can actually do machine learning within Spark. It includes lower level machine learning primitives like gradient descent. These are all topics that you actually, if you are familiar with the machine learning, you'll be able to understand these different concepts. What is MLib? It's a library with methods that have the capability to scale out across a cluster. Okay. Graphics is another component that it provides. And what exactly is graphics? There's something called DAGs that you've heard of earlier, directed acyclic graphs. So graphics actually is a library for manipulating graphs, and it uses what are called as property graphs. Now there is an example over here of a property graph. If you see, for example, over here, we've got something called vertices, and there's something called edges. Whenever you define property graphs, you have vertices and you have edges. In this case, you're seeing over here that the vertices is the name of a person and the designation. Like Franklin is a professor, RX something is a student. So there are these vertices, and these edges are telling what the role of the person is. So out here, Franklin is an advisor to the student, and Franklin is also a colleague of this particular person. So when you create these kind of property graphs, you can construct these kind of relations and depict them. For example, on LinkedIn, you can have a friend, your friend can have a friend, and you can, have a multiple, you could have a chain of different types of interconnections between friends and your connections. And that can be actually represented with a property graph. It uses vertices and edges, just like a brief summary of what it's all about. You don't have to worry about what's contained deeply into it. But if you start dealing with graphs a lot, and if you want to manipulate graph data and use data sets to generate graph data, then graphics is a great tool for that. And it comes bundled with Spark. Spark R, as we spoke about earlier, is actually R language integrated with Spark. It allows data scientists to work in R utilizing Spark capabilities. Right? So those are the essential, components that work with Spark. And now we talk about, like you said, Ravi, what are the different types of data sources? Flume is one, Kafka is another, HDFS, Twitter. So, there can be different types of data that come into the Spark platform. And this is called ingestion. In general, it's a term that we use. We say that data is getting ingested from a wide range of data sources. So Spark, and pretty much it can handle any kind of data coming from any kind of a data source. And the data which is processed by Spark can be stored in external systems. You can store it in HDFS. You can store it in databases, which can be Oracle, MySQL. It could be any kind of a, DB2, any kind of a database. And you can also present your data in dashboards as it arrives. So let's say you get some data which is coming in from these sources. You could be doing, so the Spark analysis could be going in parallel for the data sets which are coming in from all these different sources. Spark can turn that data into data sets, which we'll see how, and then store them in these data destinations on the fly. So as data keeps coming, streaming in, it keeps getting stored into these different destinations. So to break it down a little more, we are breaking up this process a little more and seeing how it works. So this input stream of data is divided into discrete chunks. So the way it works, Spark actually divides your data into discrete chunks. What does that mean? It means that, let's say that you have data, a large amount of streaming data coming in from all these sources. So you have an input data stream. It comes into Spark streaming. Spark streaming takes it and it actually breaks it down into smaller chunks. So let's say, and how are these chunks decided? It's decided by the time interval, like the amount of data you collect over 500 milliseconds, or that equates to 0.5 seconds. So you can go from that. Usually you would say, like, what are the chunks of data you're getting between 500 milliseconds to something like 5,000 milliseconds. So somewhere between 0.5 to 5 seconds as data arrives, it keeps breaking that data in those time intervals. So whatever you get at time 0 is this chunk of data. What you got at time 1, between 0 and 1, is this chunk of data, and so forth. So, as data is coming, it's getting broken into these chunks. And this goes into the Spark core engine, as we talked about earlier. The core engine can then do the processing on that data, which is divided into these time chunks, and then process them in parallel, and then have them stored over here in the different types of data sources that we've got, or destinations that we've got.
Shashi, a question.
Mm-hmm.
Are each of these RDDs actual data samples, or they are deltas of the previous versions?
Data samples. I didn't get your question. This is
Are
the.
Mm-hmm. Are each of the RDDs actual data samples, or each sample is a delta of the previous sample?
No, these are all very discrete in nature. So whatever's contained in one is not contained in the other. So
okay, so it's not maintaining a difference from the previous one. It's just the actual sample itself.
Correct. Okay. So the data is arriving. What it's basically doing is, if it's like, let's say if it was 1 terabyte of data, and it only collects, let's say, in every let's say 0.5 seconds, or half a second, it takes in, let's say, 1 meg of data. Then you can divide that 1 terabyte into 1 meg data chunks, and those chunks will get processed in memory by Spark and then sent over for storage. So that's the way it works. But each chunk is separate from the other, and there's no overlap. Does that answer your question, Ravi?
Yes.
Okay. So very interesting concept, actually. Very exciting, very interesting. It's really, really something terrific. I don't know why we didn't think of doing this kind of, in-memory analytics or processing earlier. Beautiful concept. So Spark processing, we've got, now we're talking about, up to now we were talking about the architecture and in general, the high picture, the big picture of how this whole process works. Now let's talk a little bit about how the data is processed. So actually what happens is, the way Spark works, there's going to be a driver program. So what's the driver program? It would be something like, if you're using Python or if you're using Scala, whatever language that you're using, it will have an application that's going to be running on Spark. So that application is going to essentially start using a driver program, which first creates a Spark context. A Spark context is like an object. A Spark context object is created, which interacts with the cluster manager. So if you remember, cluster manager does scheduling kind of work. The cluster manager then starts off these executor processes, and each executor process then is used by the Spark context to run tasks that are required to be run by the application. So if you see over here, this is quite similar to what we've seen earlier in Hadoop, when you have multiple different nodes, data nodes. Over here, we call them worker nodes. So the cluster manager is interacting with these worker nodes only to first get these executors started. Once the executors have been started, the Spark context then gets access to these executors, which is a process running on the nodes. And then whenever Spark needs to then work on running a task, like some kind of a program that you want to run, which is using data, then Spark context would use that process and make it run some task. So from that point onwards, Spark context can directly talk to those executors and make the tasks run. And there's a cache over there on every node, which is essentially used for in-memory processing. So the cache is something that each worker node would be containing, and Spark context has access to that cache to optimize the running the processing of the data that it runs. Okay. So talking about Spark context again and the driver program. So driver program, what is a driver program? It accesses Spark through a Spark context object. And that's all it is. So essentially, let's say if you're running something like Scala, the moment you've entered into the Scala shell, you just issue a small command called sc. The moment you say sc, which stands for Spark context, this Spark context is immediately created. And then you can start giving some kind of commands within Scala. Yeah. We'll see that in a little while. Spark context, it represents a connection to the computing cluster. And once it's created, it can be used to build the RDDs. So the resilient distributed data sets, they don't get created unless you first created a Spark context. And then once you have this context created, the RDDs, which are in the core, can then be manipulated. Talking about the cluster manager, we already talked about it, something like Yarn and Apache Mesos, right? And there's something like a standalone cluster that comes by default. So if you're not using Yarn or Mesos, you could be using a standalone cluster manager of your own, which comes bundled with Spark. Okay, so the way it works, the driver requests the cluster manager to provide resources for launching executors. And the cluster manager launches executors, which are then used by the driver to run the tasks. We already talked about this. And to explain it further, now you see once the cluster manager is done, then it's a connection directly between the driver program and the worker nodes using executors. So the driver programmer, the way this whole process works, the driver program implicitly creates a DAG, or a direct acyclic graph of operations. The DAG is converted to a physical execution plan. All this happens behind the scenes. You don't have to write any programs for this. And then the execution plan is used by the driver to execute the tasks using executors on the worker nodes. Okay. This is like going a little bit deeper into the process to understand what happens internally. So there is an execution plan that gets created. If you've worked on some other platforms like Oracle and others, whenever there's some processing to be done, there has to be an execution plan. The work of the execution plan is to figure out what's the best way to run this specific, let's say, query or a job. So let's say earlier, if you worked on Oracle, should you be using something like an index, or should I be running a full table scan to run a particular query? So all this is done internally by the engine. Right? In this case, all this is done by the Spark driver program, which basically creates this DAG and converts it into a physical execution plan to determine what's the best way of executing that particular task. And once the execution plan is ready, then it's used by the driver to execute the tasks by allocating those tasks to specific executors which have been started by the cluster manager. So executors are processes. Now we're talking about the executors out here. These are processes, and executors run the tasks and return the results to the driver. So there's an interconnectivity between the two. It's back and forth. So the driver program makes the executor do something. The executor runs a task. Whatever results are returned by the tasks are sent back to the driver program. So it's also providing in-memory storage for RDDs. So that's the job of the executors. We are pretty much coming to an end now. We just want to see at this point, what are the Spark streaming use cases and other types of use cases for Spark. One of the things is ETL, which we talked about earlier. So like you can have IoT data or data which is coming in continuously as a stream of data from sensors or devices. And you want to send that data across to be stored in data stores. So that's the ETL task. This is something that Spark can do very well. Online data enrichment. So what exactly is this? Nowadays, there's a lot of talk about, when a user visits the website, you want to understand the person's buying behavior. Let's say you're on Amazon or some other site like that. You want to understand what's the buying behavior of the person on the fly when the person is on the site, right? You want to then display some particular advertisement, which is a targeted ad to the person who's visiting the site. So what you're essentially doing is you will be having some historical data for that person who is a registered Amazon user. You want to look at the historical, preferences of that user. At the same time, you can also analyze what are the pages that that person is now visiting. What are the products that that person is now looking at? So you kind of like are combining his online instant, actions with whatever was earlier stored and saved, and then you can throw some targeted ad at the person. Like for example, you might be saying, oh, okay, he brought, last time that this person visited over the last 1 month, he was buying books, and now as you're looking at it and you suddenly see that he's again trying to find some books as he's navigating through different pages on the site. So you can take immediate action to start showing him advertisements about books. There's a 20% discount available if you go and buy, Spark streaming so-and-so book. So this is how, online data user behavior analysis is changing these days. So companies want to know what exactly is the user doing at this moment, combine it with what did he do earlier, so historical data, combine the two together and instantly take some action and try to get the customer to, like your product, or, kind of try to induce them to buy your product. So that's how things are working. Triggering event detection. So, these days, you might have noticed sometimes you suddenly realize that you're using your credit card and your credit card's not working anymore. What happened during that time? What happened was, using something, either Spark or something similar, the bank detected that that transaction that happened on your credit card is suspicious. Why is it suspicious? It might suddenly detect that, okay, from the past data that I've seen on this credit card, it used to be always transactions coming in from US and from a state of Ohio. All of a sudden, I'm seeing transactions coming in from Singapore. So that will trigger an event. So that's called a trigger event detection. So it triggers an event. So now the system knows that, okay, this could be a fraudulent transaction. The person who's using this card never informed the credit card company that he's going to be traveling, quite likely somebody has got hold of the credit card number and is trying to do some fraud. So fraud detection. So, you're now combining the historical data, which is essentially this particular credit card has been used where all earlier. All of a sudden, we see some suspicious activities coming out of a different geographical region, just as a use case. And so, it's possible that this is a fraud. They can immediately lock down your card and not allow that transaction. And so, and then you will be alerted as well. So something like Spark could do all of that. It can detect such a fraud and send an alert out to the patient, to that particular, user of the card, saying that please verify that you are actually using your card and so transaction was made on it. It's happened to me a couple of times. I use the Chase Bank, and it's good. I like it sometimes. In fact, it was a genuine transaction, but a couple of times I actually was surprised. I came back from a trip from India. On the way, I was actually stopping in London, and I did some, purchases. When I landed in US, I got a call from the bank saying, you know what, there were a couple of transactions. Please verify that you actually did them. I got a text message, and I had to, I looked at those, and they were not my transactions at all. Now, somebody was happily trying to buy something in Singapore. So I told the bank, like, this is not correct. And they immediately revoked those transactions and said, never mind, we'll take care of it. So see how things are changing. So unless we had something like this streaming use case, it would be very difficult to trap, such kind of fraudulent transactions. Another use case is like a patient's vital signs, like I already talked to you. For example, you have a wristband which is sending you heartbeats or blood pressure. You can even have mood evaluated. I worked in a company where they actually evaluated the mood of a patient by putting a sensor on him. So you can figure out the person is in a happy mood, depressed mood, or because this company was actually making some drugs for psychological conditions. So it's very important for them to gauge the mood of the person. Sensors can actually detect that using the vital signs of the person. And when they found that, they actually were able to call the patient or the patient's physician to say, the mood is really going bad, and, advise the patient to take some drug. So this is how the games are changing with the, Spark streaming kind of products. Session analysis on the web. So this is somewhat similar to what we already talked. If you have user online activity going on a website, it can provide real-time recommendations as well, right? Like suggesting movies to a user on Netflix. Like which movies should you be actually looking at? You looking at the person's buying behavior and the interests of the person. You could suggest, to the person, recommend some particular specific topics. Some use cases of machine learning. So, machine learning involves, something called clustering. It has something called classifications. So you could do something like customer segmentation. What kind of a customer? You can segment the customer market by different types of behavior of the customer or the demography of the customer. Customers belong to a specific age group, etc. So all that can be done using machine MLib. You could do sentiment analysis using MLib. Network security. So it is possible to do something called predictive intelligence. So basically, a lot of people these days are getting interested in doing network security, which means as data packets are arriving on a network into your data center or on the cloud on a server that you own, it's possible to detect those packets and figure out if there is a possibility of some threat before you actually send it to the storage platform. So you don't want the data to go and get stored if there is any particular possibility that this could be a malicious attack by some hacker. So these are the kind of use cases that we have for Spark. What kind of businesses are using it? Uber uses it. Uber uses Kafka, Spark streaming, and HDFS. You know about Uber, right? It's the taxi thing. So Uber uses Kafka, Spark streaming, and HDFS to analyze terabytes of data by collecting and converting it from unstructured event data into structured data. There's another site called Pinterest. So this site uses an ETL pipeline. to gain insights into how users are engaging all over the world with pins, and it helps them using that data to select products or buy some particular tickets for a destination. So this is another interesting application of Spark. There's another company called Conviva, which uses Spark to optimize video streams and manage live video, traffic for over 4 million video feeds per month. So this is, these are typical use cases of large data sets which are getting processed by Spark. So before we come to the end, I just want to say that there are these references that I've mentioned in this particular presentation. And I'll be getting you a hold of these different slides that you're watching. But if you wanted to real quick I always like to give you a little bit of glimpse of things that go on, let's say, Spark and all. So, for example, over here, this is a Unix, on my Mac laptop, I have Unix running, Linux actually. So as you all know, JPS is a command that you run to figure out if there's any Hadoop running. As you see, there's no Hadoop running right now, but there is something called a Spark submit, which is running. Never mind that, but basically the way to invoke Spark for me, for example, is simply to write bin/Spark shell. And if you see over here, what do I have in this folder? It's very easy to install it on a standalone machine. All you need to do is just download. You'll get a tar.gz file. So if you go a little above over here, see over here, this is the kind of a file that you can download as the latest version of Spark. And then once you download it, you extract it using the tar command. Once you've extracted it, you'll get a folder like this kind, which is basically mentioning a version of Spark. And if you go to that particular folder, let's say this is the folder, and you look at what's lying over here, it creates automatically all these folders for you. Bin, which has all the executables, configuration data. There are examples that come with it. There are some jar files contained inside. There's Python. So a version of Python is downloaded. There's R, right? And there's Yarn. You see all these products come bundled with this. And so the way you actually invoke it is really just say Spark-shell. The moment you say that, it starts Spark for you. And by default, you will see that the shell that it provides you would be Scala. So it's very easy to download, install, and invoke it, and you are all set to start on Spark. It's as simple as that. See right here? And over here, if you see what, for example, very quickly, if you were to create a Spark context, all you have to do is say SC, and it will quickly create see, it created the Spark context, and it creates an ID for it on its own. And once you've created the context, you can actually start working and using the APIs that come bundled with Spark. So, for example, if you were to create an array of numbers, you just have to say val. This is so data. Data is the variable that I'm creating of the type val, and I'm creating an array of numbers over here. And the moment you do that, it creates this array automatically in memory. Just a very quick view, just for your reference, and show you that how easy it's just to install, invoke, and start running Spark. So in the interest of time, I guess we ran over into about 1 hour of presentation. So any questions at this point from anybody?
Will you be sharing this slide with us?
Yeah, sure. What I'll do is I will post it out on the usual. What you can do is a little later today, you guys will be able to go to hadoopexpress.com/download, and from there I'll be able to provide you the download for this product for these presentations. So if you have hadoopexpress.com/downloads, I will download. In this folder, we have multiple products. Hadoop is one. I'm going to create one folder over here for Spark, so that anything we do on Spark in future as well, you'll be able to download it from there. So there will be an additional one over here called Spark, and you will be able to go to that folder and download the presentation. Okay.
Any plans for setting up a formal class for this?
Yes, yes, it's going to come out very soon. We'll be starting it maybe in about 3 to 4 weeks from now. We will be starting off a course on Spark as well. So as usual, all our courses run for like roughly about 20 hours. So if you do it online or if you do it as a classroom, class, then it's going to be 1 week. So either way, it's going to take about 20 hours of learning. And we expect to come up with an introduction and an advanced Spark course very soon.
Okay.
Any other questions, guys? Okay, thank you so much. Appreciate if you communicate, you can send me a feedback. I've mentioned that in the slide as well. So you basically can send any kind of an at hadoopexpress.com or to me, Shashi at netserpents.com. I really appreciate your presence, and I'm very excited. I hope you guys start learning this product. It's really, really very exciting. You'll like it, and as you write programs in it and start achieving something, you're really going to love it. And it's a new tool. Everybody's learning. Everybody who's working on this is learning something new every day. It's evolving a lot. And as it evolves, we are in the early stages. That's a good thing. So let's all get on board onto this and start playing with it. Thank you so much, everyone.
All right. Thank you, Shashi.
Yeah,
All
great.
right.
Thank you, Shashi.
Okay.